Permutation and combination, lecture number 1. When we talk about combination, this means this is used for NCR, which works through the selection. Whereas permutation is NPR, and this works through arrangement and selection both. Whereas factorial is used for arrangement. Factorial is used for arrangement. So what we can just see, there are two things. One is selection and the other thing is the arrangement. Selection is when we choose something. When we choose something, for suppose we need to have 4 people out of 9. So it should be 9C4. Whereas arrangement is used when we need to change the positions. When we need to change the position of people, chairs, or any particular object, that means more than one object can be arranged. Let's just work on arrangement first to understand the concept. Let's say arrange A and B. To arrange A, B, the two answers that we can get is AB, comma BA, which means we can get two ways for this. Now, if I see initially we had two letters. We had two letters. To make sure that these two letters are arranged, so what do is we apply 2 factorial. We apply 2 factorial. That means these two letters are to be arranged. So that means 2 factorial can be calculated through the calculator, applying 2, and we apply the factorial sign as well. Then we press the shift button. Whereas 2 factorial means 2 multiplied by 1, which is equal to what? 2. If I say we need to arrange A, B, and C. A, B, and C. So let's just work upon A, B, and C. If I say it's A, B, C, it can also be A, C, B. If I say it is B, A, C, it can also be B, C, A. If I say C, A, B, it can be C, B, A. So there are 6 different choices of A, B, C that can be arranged. That means the letters can be shifted, right? So if I see initially how many letters I had, we had 3 letters. So to arrange, what we can do is 3 factorial. For arrange, what we can do is 3 factorial. So 3 factorial means 3 into 2 into 1. 3 factorial means 3 into 2 into 1, which will be 6. So this particular concept means that we can always arrange the letters according to the number of letters given or any numbers given. So we'll count the numbers and we'll apply the factorial for the arrangement. Now let's just work upon arrange A, B, C, D. So now we have 4 different letters. Now, obviously, counting down or writing down all the options is not easy and simple. So what we do is we have how many letters? 1, 2, 3, and 4. So what we do is we apply 4 factorial, which will be 4 into 3 into 2 into 1. The answer for this will be 24 ways. So this was normally selection that we did. Now 4 factorial can also be done through the calculator. So now let's work upon selection. Let's say select any one from A and B. So what I can see is that I have two letters. I have two letters. And from these two, since I need to select one. So choosing one, just like randomly, we can just choose A or we can choose B. But obviously, what that selection means that how many choices do we have? How many choices do we have? So if we just see that since we have two choices, either I can choose A or I can choose what? B. So I can see there can be two possible ways of selecting the data. Either it can be A or it can be B. So for this, what we apply is 2C1. And what does 2C1 means? 2. What does 2C1 mean is 2. That means this 2 tells me the number of the ways that this thing can be selected. Either it can be selected A or it can be selected B. So out of these A and B, there are two possible points or two possible ways that you can select. Now, why do we have directly 2 as a number? Because you are selecting only one alphabet. Or selecting only one alphabet. Like for suppose if I just say select A and B both. Or the question says select both letters. Select both letters. Now, you need to understand that what the question specifically is saying. A and B both, that means both the letters are selected, or it will say select both letters. Obviously, the letters will be given. So, how many possible ways that we can take out or select? That means there will be only one possible way. So, and how do we get that? 2C2. That means you are choosing two letter out of two. So whenever you do 2C2, you will have 1. That means you will be selecting A and B. So when you are selecting A and B, you will be picking up A and B together. So you will have only one way to write it down. You will have one way to write it down. If the question would have said arrange it, obviously then I would have multiplied with what? 2 factorial. But at that time, the question specifically said select. That means this question is not linking arrangement in any particular way. The question is clear here. The question says select. So we have selected two letters out of two. When we have selected two letters out of two, so how many possible ways are there? Only one possible way is there. Let's just work upon another example. Okay. Another example, select any one from A, B, and C. So now, since I have three letters and I have possible solutions that obviously I need to select one. So there would be one possible letter out of three. So either I can have A, or I can have B, or I can have C. I can't have all the letters together. I can't have all the letters together. So if I want to select only one letter out of three, so that means I have three letters selecting only one. So how many ways that I can select? I have three ways I can select this. Either I can select A, or I can select what? B, or I can select what? C. So there are three possible ways I can select one letter out of what? Three given letters. Select any two from A, B, and C. Now, at this point, your confusions might get clear. If you are having any confusion about selection, your confusion might be clear. Now, how many letters we have? We have three letters. How many letters we have? We have three letters. And out of those three letters, I need to select only two letters. The question did not say anything regarding the arrangement. The question says just select. So if I'm just selecting, I can select AB or I can select AC or I can select BC. I do not see any other possible way to solve or to select the two alphabet out of three. That can be AB, AC, and BC. But what actually am I doing? I'm selecting two alphabet out of three. So this should be what? 3C2. This should be 3C2. And when I use 3C2 in the calculator, I should be getting what? 3 ways. So that means there are only 3 ways to select out of the 3 letters, which can be that I can select AB, I can select AC, or I can select BC. Okay, ji. So let's just move further towards, let's select any one from A, B, C, and D. Now we have four possible ways, four possible letters that I need to select from. And I need to select only one letter. So what I do is, out of four, since I need to select one, I'll be applying 4C1. I will be applying 4C1, which means this should be 4. There are four possible ways that letter can be selected. Either it can be selected A, it can be selected B, it can be selected C, or it can be selected D. There's nothing about the arrangement up till now. If the question says select any two from A, B, C, and D. So that means now I need to select two letters out of four letters. I need to select two letters out of four letters. If I want to select two letters out of four letters, what are the possible ways? I can select AB, right? I can select AC. I can select A and D. Then I can select BC. Then I can select B and D. Because obviously BA is already selected, AB was there, BC selected. So now let's just talk about, since AB was there, AC was there, AD. Now we will be selecting what? C and D. So there would be 6 possible ways that we can select. But 1, 2, 3, 4. How many letters we had? 4. C, 2. That means I need to select what? 2 letters out of 4, which is equal to what? 6. So that means 6 letters, 6 ways you can select out of these 4 particular letters. That means there are 6 different combinations that can be made in terms of selection. In terms of selection only. Select any tree from A, B, C, and D. So now the possibilities are that there are 4 letters that I need to select 3. So this should be 4C, 3. When we put down this thing in calculator, the answer will be 4, which means I can select what? I can select A, B, C, A, B, D, B, C, D, and A, C, D. So these are the 4 different possible ways that I can select any 3 from 4 different alphabets given. With this, what we can say directly is that selection can particularly be used for C, where arrangement we will be using as factorial. Arrangement means changing the position of the object. Changing the position of the object. And selecting means picking up or selecting a particular object from the total number. Selecting a particular object or the particular event from the total number. Now, case number 1. Non-repeated alphabets. Case number 1, non-repeated alphabet. Let's just say we have A, B, C, D, E, F, and G. So in total, there are 7 alphabets given. In total, there are 7 alphabets given. Non-repeated alphabet means no alphabet is being repeated. All are very different. Non-repeated alphabet means that no alphabet is repeating. All the alphabets are different. So if I just say arrange these alphabets without any restriction. Now the question clearly says arrange. The question did not say anything regarding selection. The question says arrange, the question says did not anything about the arrangement. So I can directly write down that I have how many letters? 1, 2, 3, 4, 5, 6, 7. So we can say 7 factorial can be used. What can be used? 7 factorial. The answer for 7 factorial is 5040 ways. Now, considering this, that either I can use selection or in this case only, when the question is fully arranged, that means all the letters are arranged. I can also use 7p7. I can also use 7p7. This is just to let you know, we will not be using p, we'll be using c and factorial, but this is just to let you know that we can use 7p7. How do we use 7p7? Because permutation refers to selection and arrangement. Permutation refers to selection and arrangement. When we are selecting all the alphabet, and how many alphabet do we have? We have 7 alphabet. And when we are selecting all the alphabet, that particularly means that I'll be choosing all the 7 alphabet as well. So this should be 7C7. Permutation means selecting and arranging. Permutation means selecting and arranging. So when I know that 7 factorial is being used, or I need to arrange all the alphabet, so that means for arranging all the alphabet, I need to choose all the alphabets. So this should be 7C7. Multiply by 7 factorial. Multiply by 7 factorial. Because obviously by selecting and then by arranging, it will be 7 factorial. So the answer for this will be 5040 ways. So in simple terms, why do I go forward to think about selection when it is already 7C7? So I directly use that what 7 factorial. So that is the reason I do not use P, to make sure that we as candidate understand the difference between the factorial, the difference between the C, and the difference between the P. Let's just move to part 2 for further understanding of this case. Part 2 says arrange any three of 7 alphabets. Now part 2 says arrange any three of 7 alphabets. Now the case is same. The 7 alphabets are A, B, C, D, E, F, and G. But the question has restricted me now. The question has restricted me. In the first part, the question did not restrict me at any point. The question directly said, give me the number of ways. Arrange these alphabet without any restriction. That means give me the number of ways. 7 letters can be arranged. We use 7 factorial. But now, since I need to arrange, I will be using factorial. But before arranging, I'll be what? Choosing as well. Before arranging, I'll be choosing as well. And I'll choose what? I'll choose 3 letters out of 7. So this should be 7C3. This should be 7C3 into what? 3 factorial. 7C3 into what? 3 factorial. The answer will be 210. The answer will be 210. Either I do it this way, which we will be using this way only, right? But the separate technique of doing this is, there are 3 letters. There are 3 letters to be selected. If there are 3 letters to be selected, I can select 1 from 7. So that for that we can select 7C1. That means for the first space, what I'm doing is I'm selecting only 1 letter. Then when I've selected 1 letter, how many letters we are left with? We are left with 6 letters. We are left with 6 letters. For next, it would be 6C1. Again, selecting 1 letter out of 6. Then we can select what? 5 letters. So that means this particular thing will be 7 into 6 into 5, which will also be 210. Which will also be 210. The last way of doing this is 7P3. The last way of doing this is 7P3, which will also be what? 210. Now, we need to understand here that either we can use this method, For this method, you will be selecting and you will be arranging. We can use 7C1, 6C1, 5C1 when we are representing the letters individually. Here we can do 7P3 for permutation. And you know that permutation is selection and arrangement. So what we did here, we selected and then we arranged. We selected individually, and since it is multiplied with each other, it is being arranged. And 7P3 is even same. That means it is being selected and it is being arranging. Why do I not use this P method again and again? I have been telling you that P method represents the entire question. So sometimes it is not necessary that the examiner would want you to arrange. So if the examiner does not want you to arrange, we will not be applying P. If the examiner does not want you to select, then again we will not be applying P. Then we will be applying only what? Factorial. If the exam does not want factorial, we will only be applying what? Selection. So using the direct method of 7P something will always lead you to think about P every time. And what I have seen is that candidate might end up doing the wrong solution. Now the question says arrange any 4 of the 7 alphabets. This is part 3. So since I need to arrange 4 out of 7 alphabet, so that means I need to select 4 and then I can apply the factorial as well. The answer would be 840 ways. Similarly, I can also do 7C1 into 6C1 into 5C1 into 4C1. That means this is what we are doing individually, selecting 1 alphabet at one time. So this also will be 840 ways, which means we are selecting, but we are selecting each alphabet here. And since this multiplication sign is there, that means this is applying the factorial within this 7, 6, 5, and 4. Because 7C1 is 7, 6C1 is 6, 5C1 is 5, and 4C1 is 4. Then we can also apply 7p4, which means obviously selection and arrangement together. So this will be what? 840 ways. Now, moving to the fourth one. Let's say arrange the alphabets. We already know that we had 7 alphabets, such that A and B are always together. Now, since we know that we had case 1 is non-repeated alphabet, A, B, C, D, E, F, G are the 7 alphabets. The question is arrange the alphabet such that A and B are always together. Now, in part 4, the question says arrange the alphabet such that A and B are always together. That means when they are always together, let's just write down A, B, C, D, E, F, G. A, B, C, D, E, F, G. So we have 7 alphabets, and in the question, it was directly mentioned that A and B are together. So let's create a block method. So let's just work upon the block method being used. Now, when do we apply block method? Block method is applied when any question says when 2 objects or 2 numbers or 2 alphabets are together. So we apply the block method. And how do we apply with the block method? We keep what the question says together, we keep them in a block. Now, considering this block as 1, so if this block is 1, then C will be your second, D will be your third, E will be your fourth, F will be your fifth, and G will be your sixth. Now you have 6 different ways or 6 different, let's say, alphabet that you need to what? Move around. You need to change your position. In this way, what we can do is we have 5 alphabets and the 6th one is the block. And these all 6 things are arranging together. So let's just write down 6 factorial. We're writing down what? 6 factorial. Why are we writing down 6 factorial? Because 6 factorial represents the movement of 5 alphabet and 1 block. 6 factorial represents the movement of 5 alphabet and 1 block together. But if you just notice one thing, that there are 2 alphabet inside the block as well. There are 2 alphabet inside the block as well. So what we do is, we will be applying 2 factorial inside the block too. We will be applying 2 factorial inside the block as well. So if we just work upon this thing, we see that these 6 things will be arranged again and again, and these 2 inside the block will be arranged with 2 factorial. Everything will be arranged as 6 factorial because 5 alphabet, 1 block. So this would be 5 plus 1 will be 6 factorial, and 2 alphabet inside the block will be moved with 2 factorial. So what we do is 6 factorial into what? 2 factorial because of the movement. So we end up getting 1440 ways. But now you need to understand that in the same question, gap method can be used as well. In the same question, gap method can be used as well. Now, what does gap method represent? Now, gap method represent means since A and B are in the block. Since A and B are in the block. So let's just keep A and B aside. What are the other alphabets? We have C, D, E, F, G. We have C, D, E, F, and G. So what we can do is we can directly arrange these alphabets. We can directly arrange these alphabet. To arrange these alphabet, what we do is we will be applying 5 factorial. Why do we apply 5 factorial? Because there are C, D, E, F, and G, which means that these C, D, E, F, and G will be arranged with each other. That means these will be shifted, D, E will be shifted, F will be shifted anywhere possible, E will be shifted. So that means we are arranging C, D, E, F, and G. Now, what we need to understand is this particular block AB, this particular block AB has to come in any of the gaps. So how many gaps do we have? We have this gap, 1, 2, 3, 4, 5, 6. In 5 alphabets, how many gaps do we have? 1, 2, 3, 4, 5, 6. We have 6 gaps. We can just adjust AB before the alphabet. We can adjust here, we can adjust here, we can adjust here, here, and at this point as well. So if I just want to adjust AB, how many possible gaps do I have? I have 6 gaps. To write down 6 gaps, we write down as 6C1. We write down as what? 6C1. Now, finally, what do we see is our alphabets were arranged, our gaps was filled in, because this AB can place at any 6 gap, 1 gap out of 6. And this AB will be arranged as well inside, which will have what? 2 factorial. Which will be, so when I place the gap, obviously it can also be BA. It is not necessary that it will be what? AB. It can also be what? BA. So at this point, what I see is multiply by what? 2 factorial for AB. So if I just see, the answer for this will also be what? 1440 ways. So we can apply both method, block method, and also the gap method. If I just want to go through this thing again for better understanding, what I can say is, let's just work upon arrange the alphabet such that A, B are always together. So when they are together, we use the block method. Considering that they are together, I write down all the alphabet together. 1, 2, 3, 4, 5, 6, right? But obviously I'll be creating the block of AB to make sure that AB is together. Then I counted that we have what? 6, out of which 5 are alphabet and 1 is the block. So we apply 6 factorial for this, and 2 factorial is applied for what? The position arrangement changes of AB as BA as well. So this can be applied as what? 2 factorial. So 6 factorial into 2 factorial will be 1440 ways. On the other hand, as I said, I can write down the gap method. So there are steps. If I want to put down the block of AB block. So what are the alphabet left with? We are left with 6 C, D, E, F, and G. How many alphabet do we have? We have 5 alphabet. How many gaps do we have? 1, 2, 3, 4, 5, 6. We have 6 gaps. We can put down AB block in any one out of 6 gaps. So 6C1 for this. And then when we place the gap, we made sure that we have that block arranged as well, because AB can also be written as what? BA. So when we are arranging inside the block as well, we'll write down 2 factorial for the block. So the answer for this will be 1440 ways. Here we have another example, arrange the alphabets. Now, how many alphabets we know? We know we have 7 alphabets, A, B, C, D, E, F, G, right? Such that A, B, and C are always together. So that means making block of A, B, C, D, E, F, and G. So we know that we have block of A, B, C, and we know that we have 1, 2, 3, 4. 1, 2, 3, and 4. And we know that this will be your 5th block, will be your 5th. So 4 alphabets, and 5th one is the block. So if we arrange this using the block method, this would be 5 factorial in total, and 3 factorial for the alphabet arrangement inside the block. Alphabet arrangement inside the block. So because this ABC will be arranged as well with 3 factorial, G, F, E, D are 4 alphabet, and this will be your block as well. So 4 alphabet and this block will be 5. 5 factorial to arrange all of them, and 3 factorial to arrange the A, B, C. So this way the block method will be used, and you will be getting the answer as 720 ways. Similarly, if I use the gap method in this, what I know is that in A, B, C are always together. So D, E, F, and G are the alphabet that are left behind. So to arrange this, what we do will be 4 factorial. How many gaps do we have? We have 1, 2, 3, 4, 5 gaps. We have 5 gaps. So we can just put down that block in any one gap. Out of five gap, if we select, we will be using 5C1. And then we will be applying 3 factorial for the alphabet movement inside the block. Alphabet movement inside the block. So you need to understand this 3 factorial is for the alphabet movement inside block, right inside block. This 5C1 is putting down block in any one gap out of 5. This 4 factorial will be arrangement of the letters that are not in the block, they are outside and they are being arranged as well. So the answer for this particular question will again be 720 ways. Okay, Ji. Now the example question says in the same case of A, B, C, D, E, F, G non-repeated alphabet, arrange the alphabet that they either start with A or B. So again, there are 2 ways to do it separately or to do it together. So if I say 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So if I just say that it starts with A, if I just say that starts with A, then that means your B, C, D, E, F, G will come here. Similarly, if I say that I start with B, so this means A, C, D, E, F, G will come here. So all the other alphabets will eventually what? Arrange themselves, but it starts with A, that means this is your fixed position. This becomes your fixed position. So moving the technique of fixed position here, so what we understand is that since this is fixed positioning of A and B, so that means your A will not be moved and B will not be moved. But all the other alphabets such as B, C, D, E, F, G and A, C, D, E, F, G. And these 2 options will be moved and either of them can be followed. Either the first option will be there or the second option will be there. And when you have or, what we do is we add the 2 options together. So if you see, what we can get from here is the 6 factorial will be used to arrange all the alphabet in when it is starting with A, and 6 factorial will be used when it is starting with B. When we use 6 factorial, the answer is 720, and we use this answer is 720 as well. But this both the possible options will be added. Either it will start from A or it will start from B. The answer will be 1440. Or there is another way. What we did was we fixed the position initially here. We fixed the position here. Now I'm not fixing the position. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Which means in this particular point, either I can have A or B. Because this is my first position, right? So at first position, I can have either A or B. Out of 2, I can only select 1. So I can use 2C1. I can use 2C1. Whereas if A comes here, then there is a possibility that anywhere B can also come here. But if B comes here, then in this A can come and obviously be arranged, right? So that means how many alphabet do we have? 1, 2, 3, 4, 5, 6. We will have 6 remaining alphabet. For that case, what we'll do is we will be applying 2C1 for A or B, 2C1 for A and B, and we will be applying 6 factorial for what? C, D, E, F, G, and A or B again. Because if A is chosen here, then here we'll have B. If B is chosen here, then here we will have A. So the answer again will be, the end answer will be 2C1 into what? 6 factorial. The answer would be 1440.